So good day everyone. For today's video, we're going to solve another integral problem. So as always, the first thing that we need to do is to distribute the integral sign as well as the dx to this expression. Integral of fourth root of x cubed dx plus integral of cube root of x raised to 4 dx. So the next thing that we need to do is to transform these radicals into an exponent form, because in that way it would be easier to evaluate this expression. So the rule states that under the laws of exponent, x raised to a over b is equals to square root of x. So in this case, a refers to 3 and b refers to 4. So we'll apply that. So integral of x raised to 3 fourths dx plus integral of x raised to 4 over 3 dx. So the next thing that we need to do is to apply the power rule for integration. Integral of x raised to n dx equals to x raised to n plus 1 over n plus 1. X raised to 3 fourths plus 1 over 3 fourths plus 1 plus x raised to 4 thirds plus 1 over 4 thirds plus 1 and plus c. So just need to add x raised to 7 fourths over 7 fourths plus x raised to 7 thirds over 7 thirds plus c. And this part, we just simply need to reciprocate this one and multiply to the x. So the reciprocal of 7 fourths is 4 sevenths times x raised to 7 fourths plus the reciprocal of this is 3 sevenths x raised to 7 thirds plus c. Now this is the final answer. Now let's proceed with the verification. And then we'll proceed later on to graphing. So our original problem is x raised to 3 with the index for the radical plus cube root of x raised to 4. And our answer is 4 sevenths x raised to 7 fourths plus 3 sevenths times x raised to 7 thirds plus c. So the y prime of this would be 7 fourths times 4 per 7 x raised to 7 fourths minus 1. We just simply apply the power rule for differentiation, which is e over dx x raised to n is equals to n times x raised to n minus 1. So plus 7/3 times 3/7 x raised to 7/3 minus 1. And the derivative of any constant is always 0, which is d over dx of c, any constant, is always equals to 0. So we just simply need to multiply. We know that 4 to here, we just cancel 4. Just cancel this out, as well as this, as well as this one, as well as this one. So we're left with x, and 7/4 minus 1 is simply 3/4 plus x. 7/3 minus 1 is simply 4/3. And from our original problem, it is the fourth root of x cubed plus cube root of x raised to 4. So how is this equal? Again, from our earlier rule, laws of exponent, an exponent can be transformed into a radical. So we just simply write x. So this is the exponent, the a, and the index plus this one, x raised to 4. So basically, as you can see, they are equal. The statement for this equation is correct. Now we have done the verification. Let's proceed now to graphing. So this is how the graph looks like. We just simply put our answer as well as the original problem, apply constant. It can be any constant. This is just set to 10. We can set it to something else, maybe 100. And it would still be the same. You can set the constants to any number you can think of. And this is just how it would look like in the graph. So now we have done graphing. So we have done everything from the solution to verification and graphing. So hopefully you're able to grasp the idea of how to solve every problem. This is not just about integral problems. You can apply this to any problem.